Hello everyone, my name is Daniel O'Hury, and today we're going to go over linear models. So I apologize if some of the technical things aren't all up to par. I've learned and I've found newfound respect for those who make these types of videos. But today we're going to go over linear models. And the scenario we're given is the adjusted fuel economy for cars and light trucks in 2008 was 21.0 miles per gallon, and in 2013 it was 24.1 miles per gallon. So the first thing we have to do, or the first question given to us, is write an equation. And so from that, the first thing we have to do is define our variables. And we're going to use variables that make sense. I'm going to move my cursor over here. We're going to use variables that make sense. So we're going to move beyond the XY dichotomy, because that has nothing to do with what we're doing. So my dependent variable, I said G. Let G equal the average adjusted fuel economy. And I did that because fuel economy has to do with gas and G, so there we go. My independent variable, time, I said T because it's easier to remember. And the important thing I did with this is I quantified. I put in units what I'm looking at. So time is going to be number of years since 2000. Let me underline that for y'all. Number of years since 2000. So do you notice a mistake already in this? The mistake is I haven't given a unit to my average adjusted fuel economy. And what we're going to be dealing with is miles per gallon, because the word problem has asked us to do things in miles per gallon. Let me get that set up. There we go. Miles per gallon. Let me put that in parentheses. I'm going to go ahead and move that there. Okay, we have our scenario, we have our question, and we have our variables. So, what do we need to do now? Well, when you're dealing with linear models, you are going to start off with your slope, with your points, and to get points, you have to look back to the scenario we were given, right? So we're going to get our points from the numbers 2008, 21, 2013, and 24.1. That's where we're going to get our points. So our points are going to be, so we're in math, always label what you're doing so people can see that you're not just pulling numbers out of nowhere. We're going to have 8. Why are we going to have 8? We're going to have 8 because 2008 minus 0 is, 2008 minus 2000 is 8. So again, because we because we gave this units and quantified it, we're going to deal with dates that aren't outrageous, because there wasn't fuel economy, average adjusted fuel economies in the time of the dinosaurs. So we have to deal with the dates that make sense. And our second point here is going to be 21. In this ordered pair, we're also going to have 13 and 24.1. Now we have to go ahead and calculate the slope. And we represent slope with a lowercase m. And of course we know slope is going to be the change in the dependent variable divided by the change in the independent variable. So in our case, slope is going to be the change in G divided by the change in T. So the change in the average adjusted fuel economy divided by the change in the number of years. Awesome? Okay, let's continue. Now we get to plug in what we need to plug in. We're going to put in 24.1 minus 21. And you see where I'm getting these numbers. I'm getting these numbers from here and here. Okay. And then, because I want to follow the order that I've done it already in, I'm going to pick 13 minus 8. So, you are going to get a fraction here. If you punch this out in your calculator, you're going to get a decimal. Now, when you're dealing with linear models, you never, ever drop the decimal in the slope. And never are you going to confuse, please don't confuse fractions and decimals in your equation, because then it looks like you don't know what you're talking about. Pick one. And for the sake of cleanliness and order and the fact that I don't like looking at decimals, I'm going to deal everything in fractions until we get to the word answer, because this is whoopwa, word answer. And that is when I believe it's acceptable to put the decimal in. But as for now, it's better to deal with slope in the exact. So we're going to get a fraction of 31 over 50. And of course, that does equal a terminating decimal, and that terminating decimal is 0.65. But honestly, just keep everything in fraction form until you get to the word answer. So, now that we have our points and our slope, the next thing to do is to create an equation. And we don't have to do the silly way by going straight into y equals mx plus b. We already have points and we already have the slope. So we're going to make our equation in point-slope form, because that's easy. Why waste time in doing something that's harder? And if you remember, point-slope form is going to be y minus y sub 2 equals slope times x, that's an x, minus x sub 2. Now that's great, but again, x and y have nothing to do with what we're trying to represent here. We're trying to represent fuel economy and years. So let me get rid of that, and we're going to just put it all into perspective to our linear model. And that's going to be g minus 21. So I'm picking the points from right here, 21, and I'm going to pick my points from here too. And this is because these are cleaner to me. Why am I going to mess around? Why am I going to mess around with this decimal when I have really nice numbers right here already? So there's no point messing around with decimals when you have nice numbers. Equals slope, and we know our slope is 31 divided by 50. And we're going to do t minus 8. There, we've done it. We've made our equation. We've answered the first problem in this linear model session. But because of the other questions that are going to come up, let's go ahead and put this into y equals mx plus b form. And you can do that simply by just adding 21 to both sides and distributing. Okay? So here's going to be our y equals mx plus b equation. We're going to have g is equal to 31 over 50, or 31 divided by 50, t plus, so this is important because we're going to get another scenario where we can either get a fraction or a decimal. And again, because you don't want to start confusing things, it's better to leave it in a fraction form. You're going to get 401 over 25. And that's the right way to write that equation. Because if you, and I'm going to write it over here, so in a different color even, I'll write it in red, the no-no color. I'll write it over here. If you did write your equation as g equals 31 divided by 50 plus the decimal of this fraction represented as a decimal, which is 16.04, you've done a terrible, terrible mistake, because now you've started to confuse fractions and decimals in your equation. This is not right. That is not right. That is incorrect notation. This is the no-no box, so don't do this. Don't start confusing fractions and decimals. So this is wrong. This how I wrote it the first time, this gets more check marks, because this is, you want to keep your equation in the proper form. Don't start confusing things. Okay, moving on. We have our equation. We can now answer the other questions. So number 2, interpret the slope and the vertical intercept. Okay, let's start off with the slope, and we know our slope is going to be 31 divided by 50, and this is now, because we're doing a word answer, where you can put in that decimal. And it's going to be, and this is how you're going to format your answer. According to the linear model, oh goodness, according to the linear model, keep this introductory clause in there because you're trying to state your case, and what are you referring back to? You're not referring back to Santa Claus. It's not according to Santa Claus such and such. It is because you created a linear model that you are going to make your claim. So according to the linear model, the average adjusted fuel economy in cars and light trucks increases, here's the decimal, 0.65 miles per gallon a year. And again, important to put in the units that you're talking about. And since we know it's a constant rate of change and we're comparing it to time in forms of years since the year 2000, we're going to have a year, that phrase in there. Okay, that's fantastic. Now, how do we interpret the vertical intercept? Again, this is going to be another word answer, so we're going to have another decimal in that answer, and it's important to know what that 401 divided by 25 means. That is the point in 2000, that was the average adjusted fuel economy. That is where our graph starts, and because that's where we decided to measure from. So that's what the vertical intercept means. So our vertical intercept is, according to the vertical intercept, this is our answer, according to the vertical intercept of the linear model. Again, it's important to have this phrase here because you need to tell people what you're talking about. The average adjusted fuel economy in 2000, because that's when we started measuring in our linear model, was 16.04 miles per gallon. Okay? Now, with that information, we can now start using our linear models practically and start answering some questions. So moving all of this off of our whiteboard, we are going to get this question. This is our final question for today, and we're going to look at how to do this practically. And our question is, what is the average adjusted fuel economy this year, 2015? Okay, great. First thing we need to do, always, is define our variable. So I'm going to do let t equal 15. Again, because 2015 minus 2000 is 15, and we decided to start counting from the year 2000 so we don't have any outrageous dates. Excuse me. Okay. So now we're going to pull up our equation. And we're just going to plug in the 15 where it belongs in all of this and get our answer. And so we're going to go, the average adjusted fuel economy equals, for the 2015, is going to equal the slope times 15 plus 401 divided by 25. And let me make that clear over here so we're not confused as to what we're referring to. There. Okay. Now, this is the point where you might be taking a test and you can just pull out your calculator. Fantastic. And it makes a whole lot of sense to pull out your calculator. And notice how this question is asked. It says, decimals make sense for the answer to this question, since it is an average, and we're not going to round our answer, because then you've totally destroyed the whole point of all of this. So no rounding. Keep it how it is. And plus, when you go to a dealership, you're not going to see the fuel economy listed in fractions. So when we're doing the word answer, we're going to deal with decimals. But for the rest of the process, it should all be in fractions. So we're going to get 25 and 34. 25.34 miles per gallon. And out of curiosity, I went to go check what the fuel economy was actually for this year. I couldn't find it, but for last year, it was, according to the Chicago Tribune, 25.6 miles per gallon for 2014. And that's because they measured all new cars, so not the light vehicles that we were measuring. And also, the real world has a whole bunch of variables that we can't deal with. And we're just doing this for our linear purpose. But it's still pretty cool that our linear model was able to predict right around where our the miles per gallon actually is. And also in that Chicago Tribune article, it talked about the goal for adjusted fuel economy. So they said the goal for 2025 was going to be about 54 miles per gallon, which is a huge leap by 2025. So my assignment for y'all is to use what we've learned here and find out what the average adjusted fuel economy is going to be 10 years from now. What's it going to be? Question mark, question mark. So go ahead. With all the steps and tools that you've learned, you should be able to find this out. Thank y'all so much for watching this video, and I hope y'all have a good holiday season and a happy new year. Thank you.